My application had inconsistent crashes. What happened? Well, this actually happened to a fairly famous application. I know, have any of you played Angry Birds beta, the original beta that came out of Angry Birds? And did any of you had it crash? No one had it crash. Well, that's pretty good. Well, the original beta of Angry Birds crashed on a lot of devices. And the reason why was that they were actually opening up two different threads, and they were sharing the JNI context across those threads. And what this actually ends up looking like, when you finally end up getting a crash, is somewhere in Dalvik something has gone wrong. And there's a very, very good chance that it's not a bug in Dalvik. Let me tell you that. It's probably in your code. And it turns out there's a race condition. And some people actually found that by tapping on the screen, they can get the game to work a lot better. My game runs slowly on older Android hardware. What turns out, older Android hardware is really, really bad at handling vertically textures. Specifically, the default comes into a 1-chip. It really likes having 16-bit textures thrown at it. So you can actually do that. You can look to see, well, am I running an OpenGL ES2 handset, and I can actually convert your textures on the fly into 16-bit. There's a way in the framework to do that. Not a bad way of tackling the problem. Another thing you can do is to fill rate the problem. You can actually call set fixed size on your surface. This will actually make the framework automatically scale up your view. So on some of the early handsets, like the Milestone, fill rate was kind of a problem. It was running very high resolution without a huge amount of fill rate. So you can actually, what you're more concerned about is getting a high number of frames per second. You can actually do that by calling fixed size. And then finally, the chipset manufacturers all provide tools. Qualcomm and PBR and Imagination Technology and NVIDIA all provide tools to help you optimize your application. You can actually look at what's going on inside of OpenGL, see what's happening, and then actually try to find out what's slow in your code. Okay, you've done all that, my game can still run slowly. Well, there's a couple things you can do to make sure your application doesn't show up for all the people on Android market. That, and you know what happens is that you put it out on Android market and someone says, nice cyanogen modded G1 crashes with your application, 1 star. Oh, I hate when that happens. So what can you do to try to stop that? Well, one is you can filter on OpenGL version. Even if you're not using OpenGL 2, you can actually filter on OpenGL 2 and that eliminates all those older handsets. The other thing you can do is you can actually use, as I mentioned before, CPU version. So you can build only an ARM7 native library, and the Android market will filter out the slower devices. It's not perfect. You might actually end up filtering out a device or two that could actually run your game. So, but again, it might be worth it. My game was built with a certain proprietary texture format. So Android encourages innovation in hardware. And that's great. It means that we're constantly getting newer and faster and more exciting things to work with. But it also means that there's a few hardware differences, and you really see those when you're working in OpenGL. So this means that if you just ship PVR-TC, PowerVR texture compression, or API texture compression textures with your application, it's not going to work on every handset out there. So there's a couple things you can do about that. One is, most of the OpenGL ES2 handsets actually support something called EPC1. Now, there are some ways in which EPC1 is definitely inferior to these proprietary formats, but if you don't need alpha, it's actually not that bad. The other thing you can do, and a lot of people do this because they're trying to get around the 25 megabyte limit that currently is on the Android market, is you build an asset server. And then you can actually look at the GL extensions that are currently being supported by your device and actually see, which textures do I need, and have a couple of them download. Again, it's kind of cool. No one's done this yet that I know of, but this is a perfect example of something you could use app engine for. Honestly, is building an asset server. And I've actually, I'm hoping to someday cook something out that no one else does. But come on, someone in the open source community build an asset server. It's totally needed. All right, things to consider. As you probably know, most of you being Android users are trained to use keys. Make sure the app key does something. Whether it either dismisses the dialogue or pauses the game or exits if you're on the main menu, don't make it do nothing. And I bring back the example of Angry Birds. And if you're ever in the middle of playing Angry Birds and hit the back key, it does nothing. Android users hate that. I hate that. I want to at least bring up something and say, pause. But no, I actually have to go and hit a virtual button on the other side of the screen in order to make it go back. It's just jarring to the user experience. So don't follow their lead. They did a lot of other great stuff in UI, but that's a fail if you don't support the platform. Let the volume piece through. The volume piece should always be able to control the sound volume of the kind of stream you're playing. So you should always set the volume control stream if you're going to be playing music, stream music. And then you just let the volume feed through and the platform will always adjust the volume. Some people don't do this. It's really frustrating when you boot up a game and you try to use the volume key to adjust the volume. It's really, really loud and annoying and driving people crazy. You can't because they haven't let those keys through. And finally, unlike on some other platforms, the home key does not quit your application. It goes into a dormant state. Your application should respect the life cycle. When the user comes back, it should be paused exactly where they left it. Even if it had to be swapped out by the framework, even if you ran out of memory and your app was killed, when they come back, it should be back again, even if you're using NDK. So this is something to think about when you're looking at an NDK design. So you're going to have to account for this.